Hi, taking over from Floor. My name is Sjoukje and I'm the Microsoft CTO for Capgemini and the Microsoft Azure MVP. I have the honor to introduce our next speaker, Daniel Paulus. Daniel is a DevOps consultant at Fullstack and he will help us to unleash the power of containers with Pulumi and Azure Kubernetes Service.
Thank you, Sjoukje. As in the previous talk, I'm going to talk about Pulumi, and I will take you to a journey from containers to AKS and how I can do that in a more modern way. But to take you there, I will first go back to the old days when I first started out with IT. I worked for a company about 10 years ago where we had old school servers. We would go to the data center, we would put them in a rack. One server would run one application. At the time they were built in Ruby, and every server would run a different version of Ruby because all applications would run different versions, and it was a pain. To make that life a little bit better, we started using Chef. Chef was based on Ruby, so we would do more or less automated builds, and we would have a faster setup of a new server. At the time, we moved from the old servers to a more cloud approach, where we still would have the old data center. We would go hybrid. We would use VMs. Some of the developers would start to use containers, but it's all local and not shared with the operations team. And then we would start to use Terraform in order to set everything up. The split was very clear. Operations used Terraform, the developers used their own languages. There was not really sharing, and it was a pain. The new modern approach would be that you have a fully dynamic situation. You have many different services that talk with each other. You would have containers. You would have something as Kubernetes. You may even use serverless, like Mark told in the first talk. And at this day and age, we would use cloud, just public cloud. And a tool as Pulumi works great because you can use your own development language to write the code. I will show some demos that are based on Node.js. I will use Typescript because I see a lot of usage of Typescript at my current customer. So if you've never done anything with infrastructure as code, let me take you back there for a moment. Why would we want to use infrastructure as code? Installing a server by hand with a bunch of bash scripts, and every time something would fail or a package would not be available, things would hurt. There would be errors and everything would go on fire. With this new approach, everything is in code. It's repeatable. It's in Git. You can use the same practices as the developers do. You can do code reviews. And it's all within the same workflow. As I talked about modern infrastructure, this is what I meant with modern. It's real languages. It's exactly the same as your developers write. So you, as an operations engineer, I would love if you would be in a DevOps role where you would be actually part of a dev team. But let's say you're not, you can learn from them and you can ask for their help to write your infrastructure code. But also for the development teams. I see a lot of development teams right now that struggle with operations responsibilities. there's simply not enough operations people to support all the developers that want to use cloud technologies. So let's share and let's learn from each other. With a tool as Pulumi, we can make that happen. And I will do my demos in vscode to show you that you can use any editor that you like. It will work. If we then go to the deploy stage, before I deploy new infrastructure, I would like to see what is going to happen. I would like to make sure that I don't blow up my entire stack. And as an operations engineer, I work a lot with CLI tools every day and mostly the entire day. So having a tool that I can use from the command line is great. And I will also show you an example with Azure Devops, how you can use Azure Devops to deploy a stack. And then there's this new stage where a lot more security people start to investigate what this cloud thing is and what we as development teams can break in the cloud. If you use the software as a service offering, there is a complete activity log within the SaaS solution. So if you're a CISO and you want to check out what's happening, who made a change, who did something, who broke it, it's all being tracked. So let's go back to how Pulumi works. Basically, in this code snippet, you will see that we create a resource group, and in that group, we create a VM. In order to do this, the software must understand that it first has to create the resource group and then has to create the VM. It's all very important that we do that in the right order. So what we do is we define or we link them up by saying that the resource group name is based on the resource group name of the object above. So it understands the order of things. In order to show you how that works, I will have a short demo. Let me make this a bit bigger. So this is vscode in my terminal view, and we simply start by executing Pulumi new within the folder that I just created. It will come back to me with a bunch of options. And as I told you, I will go with TypeScript. So I choose for Azure TypeScript. I can choose from many of the providers that they have available. It will now start to ask me a couple of questions. And these questions will help me to set everything up. So we will go with the name demo1. I don't have to give it a description for now. And then we have to give a stack name. A stack name is very important because we can use acceptance or production, and that way we can split everything up for settings and other organizational information. We will use the public cloud, and because I'm in the Netherlands, I will say West Europe for now. Because it's Node.js, this may take a while. All right, and what it now did, it created the folder structure with a bunch of files in there. The most important file for now is the index TypeScript, but as you can see, it also made a dev.yaml with some of the settings in there. If we make another stack, it will create another settings file so we can split the settings up. As you can see here, it's already scaffolded with a very basic deployment. It will create a resource group. In that group, it will make a storage account, and it will output us the connection string. There's a very important thing to understand here. This is the name of the object. It is not the name of the storage account. We can provide a name for the storage account if we like to, but right now it will use an auto-generated name based on the object name. So what will happen here is it will append a unique identifier string at the end of storage. In order to show you, I will bring the stack up. And as we ask for the details, you will see that it will make a resource group which has the name resource group, but also appended the unique identifier to it. And the same thing for the storage account. For now, let's apply this. This will take a moment and it's done. As you can see, we now have a connection string that we can work with. But we have also have the state ready, so we can ask about the state. My demo broke. Not sure why, but it now stores the state inside of Pulumi. So we can see what it made. If you want to store the state in a different tool, we can change that by logging in with an Azure blob. So right now I don't have one to apply, but if you want to use your own backend storage, that's fine. You can use Azure, you can use Google, or you can AWS S3 buckets. That will all work perfectly. So let's continue on by why I believe that having a modern tool like this is actually great, because as you saw, it's just Typescript, which basically means that we can test everything that we do. So let's create again a new project. Just use all the basic and only change the region. What I'd like to show you in this demo is that we can use testing in order to validate our package. let's do some copy pasting because we run to time otherwise. I will add a bunch of extra packages that we need in order to make the testing work. I have pre-made the testing spec. I see that I have an issue. Oh yeah, okay. Live coding in a presentation is always a challenge, but it seems to work. Okay, so what this script does is it basically reads out all the Typescript files that we have in our project, and it then takes out only this file, and the rest will be used for testing purposes. So let's create a storage spec. And in the storage spec, we will first import some of the basics that we need. And as long as we haven't run, it doesn't know the state, so it can't really test. So the dry run, if we only dry run, it will not work. But we can now start to say things as for the storage account that we have, we want to make sure that it should have an exact name. So not the auto generated name that we had. That will be an async method because we have to wait on the object. And we will now read out the name of the storage account. So storage account per name, and we expect the name to equal let's go with Pulumi demo 2 because a storage account can have spaces or special characters in it. Okay, so if we now run, oh, I have to fix one thing in the so in order for this to work, we have to export the storage account. So we make sure that we do that, and we have to include the run test methods so that it understands that it has to run the test. So if we now run Pulumi up, you will see that it was running the Mocha test. we have to apply it first because once again, it cannot be checked if we're still in preview. And the check now will fail because we haven't set the name of the storage account. A little bit of a spoiler here, but so one is failing. It should have an exact name. It's not passed because it has a random name. Well, it should have had a predefined name. So let's fix it. It is quite simple by specifying the name, which we set to Pulumi demo. And if we now apply it again, so this becomes extremely handy when you work with other dev teams that have mastered the testing part, because right now you see it has an exact name. You can maybe see that next to an exact name, we could also check for things like it should be in West Europe region, right? Especially if you do things with GDPR and you want to make sure that your data is not in the US, then you could add tests like check the location if it's equal to Western Europe, for example. And you will see that will pass as well. In order for time, I will skip a little bit. Another thing that we can do as it is real code, we can also do things like loops. And that's where the real fun comes in, because let's say that for every application, let me fix something. I already had a demo tree open, but not anymore. So let's say you have a bunch of web servers that you have to launch, which all have the same basic setup, but you will need them for HA or anything like that. We can make a class web server. So let's say web server Typescript. So we have a class web server which extends the basics, and that web server has a network interface. and a virtual machine. And this VM is based upon the name of the loop that we will give it. So we can then use this class here and let it create a few things. So in order of time, I will paste everything in. So what I did here is I included a new package called Pulumi Random. We will use this package to generate a password with a length of 20, and we will make sure that it has the special characters enabled. What we want to do here is we want to make sure that this password is never put in any kind of log, not in the state, never. It has to be secure. So I added an additional output. We generate a resource group. We make sure that there's a virtual network with the basic name, with the basic address spaces and such. And then here the fun starts. So until we count to 3, we generate a new server with a name, with an integer count, and then we will make sure that it's generated based upon the class web server. And if we now run Pulumi up, I will not run this because it takes quite some time, but I will show you what it will build. It will create 3 web servers within a resource group and with a virtual network. So don't. So now I want to show you how we can use this in order to build an awesome AKS stack with some containers and Helm charts and everything in there, all managed from Pulumi. So keep in mind that what I will show you is demo state, and I would never run that in actual production, but we can do cool stuff. So let's in it, and let's start the fun. So we don't need this, but we do need a bunch of packages because everything within the framework or within the SDK is split up into separate packages. So if I want to do things with the Azure AD, I have to include the Azure AD package. If I want to do things with a Kubernetes cluster, I have to include that as well. Same for Docker. And we're going to start out by creating a password. And we have to have a resource group, which right now I have given the explicit name of Playground. And in order to make an AKS cluster work, I have to have an AD application. So that's why I am using the Azure AD module, so that I can generate an application, which for now I have given the name AKS. We also have to have a service principal. So let's create one of those as well, based on the application that we made first. And it needs a password, so that's why we created the password above. And as you can see, we're still in actual code. Every step that we needed as a we can do in TypeScript. But the most easy way that we can make this work is simply call and create a Kubernetes cluster. It's a container service which has a few options that it needs to have by default. So that's why I filled in all these details. One of the strange things that I bumped into is that it needs a setting for the Windows profile, because if we don't set this, it will keep updating the cluster with a new cluster every time we run Pulumi, which is strange. I have to figure. I'm not sure yet why this happens. I will find that out at a later moment. But for now, this will work. And if we run this, we will have a basic empty Kubernetes cluster, which on its own is not very special. But we can start to do cool things to add. Let's create a container service as well. So we make sure that we have an ACR ready to go inside so that's our private repository. And as a developer or as a development team, we create a Node.js application. So how cool would it be that in the same deployment, I can create this application from my Docker file, all in one repository. Okay, let's create a Node app. And I do need to write it correctly. And within that Node app, there are 3 files. But the most important one is, of course, the Docker file. Oh. And if we have the Docker file, then we could do something fun by saying, so build a new image that's called Node app, put it inside of the registry, which we just made, and build it based on the custom image folder that we have here. So it detects this Docker file, it will build the Docker file and upload it into the just made ACR. All in one go. And if we can also, in the same time, say we do some things with Helm. But in order to use Helm, we need to make sure that we have a provider, because it has to interact with the cluster. So it uses the kubeconfig in order to do that. And then we can say use Helm, in my case still v2. I might upgrade to v3 anytime soon now, and use a chart. I wanna install the stable version of Jenkins, which right now is 1.10 in the Helm charts, and I want to provide it with a Kubernetes provider. And at the same time, I want to make sure that I export the cluster name, but I also want to export the kube config. So I can, with Pulumi up, I can get everything that I need in order to interact with this cluster. If I want to run this right now, it will take up to like 15 minutes in order to complete. So I did that in a bit of pre-work. Right here, let me make that a little bit bigger. You can see everything that we just did. And my node application is also filled in. And I also made sure that it has been run with Azure Devops. And thankfully, the latest state is green. So this basically means that right now in Azure, we have a resource group called Playground. In there, we have a registry, and in the registry, we have a node application, which is built all right. And to zoom a little bit on the Azure pipeline, there is a package in the store that you can install, which makes it very easy to run Pulumi from your Azure build pipeline. You can simply make sure that you have a subscription with enough power to make that happen. You run up, you give it some of the basic args. In my case, I want to make sure that I point it to the right folder, and I use the SAS right now, so I have to provide that as well. After that, you will see that you install Node.js, you install Helm, you make sure that you install all the npm packages, then you run Pulumi, and if everything is gone as planned, you're entire green. Let me see. All right. So right now I want to show you that I can actually interact with the cluster. Because we have the state and the stack, we can also output any var that we have exported in a previous run. So right now, I have exposed the kube config, which just contains everything we need to talk with the cluster. And you can simply run any command that you'd like, and you see that we have one Jenkins master up and running, and we can even say port forward and we are attached to our Jenkins. So as you can see, there's a lot of cool stuff that we can do by simply using a tool like Typescript to use the same language as we did to build our Node.js application. And you are all good to go with one Pulumi up command. So everything that I showed you here, it's all free to get started with. As we speak, you only have to have an Azure subscription in order to start with AKS. The AKS master planes are free, but you do pay for the nodes that you use. So the bigger they are, the more expensive they are. And one tip that I can give you, simply run Pulumi destroy, and it will make sure that all the resources that we just made are offline. That's it for today. Are there any questions?
Yes, there are some questions in the chat. First of all, thank you for the talk. I really enjoyed it, especially the mechanical keyboard, which really is good to also not only see you typing, but hear you typing as well, which makes it less boring. So the first question we're going to answer, I hope, is from Gerrit. And he asks a great question, I think, because he asks about the useful use cases for building and pushing Docker images to a registry with Pulumi. This immediately became a discussion with Andreas, because Andreas said, well, I'm not a big fan because I don't want to use different ACRs for different stages. So what's your view on this?
Right now, I'm in a situation where we do have different ACRs for each of the stacks. So, and the reason they have that in place is because every ACR has different rights. I think it's a bit of overkill, but you can also push to an already existing ACR. You don't have to you don't have to make one. You can import state into your stack as well. So if you have an existing resource with Pulumi, you can also point to the exact I think it's called URN within Azure, and it will import it. It will not change it. It will only import the state, and it will warn you if the state that you have configured is different than the state that you are importing, and that will work. So the only thing I did this in this demo is to show you it's possible. So you can do a lot of strange things with TypeScript, which is also why I like to use it for a demo. And so I'm not saying you have to push it, but you can push it. That's the key takeaway here.
You showed us because you can. That's great. Love it. So Sebastian asks, is there a best practice for splitting code in several files?
Well, I think you should look at the TypeScript best practices here. As soon as you reuse a certain piece of code, it makes sense. So as I did in demo 3, where I split up the web server file as a class, then it makes sense to split it to a separate file. But you can also, so you can include or import anything that you like with in top of the stack. So you can make sure that if I have a lot of configuration settings, I can make a config.ts and include all that config there, and then simply include it to the files that it needs to be included to. But I think that there's a lot more dev people that know a lot more about the best practices than I do. I'm only starting out as that, so.
But you're sharing your learnings, which is cool. So there was also another question. The last one we'll do in before the break. Is there a special reason why you wouldn't create the AKS cluster from Pulumi? What's the difference with using Terraform? And is it because the setup you were using for this demo?
So the difference for me is that it's just real code. This is not the Terraform language. This is real code. Every developer that knows TypeScript in our company knows how to write this, and therefore it's different, and it's also the same. So it uses the same providers under the hood as the Terraform does. The only thing is it's not in the Terraform language. It's in TypeScript, and for me that's the most important reason to choose for Pulumi. You can use the language that you write your code in, and you don't have to learn anything new.
Cool. Okay, well, thank you very much for your talk. Also, thank you, dear people watching this stream, for asking your questions. Keep them coming. You can always mention Daniel on Twitter and ask any question in the YouTube chat. I hope he will stick around for a little bit. So this concludes this session. We're going for a short break for about 30 minutes so we can set up the next speaker. So enjoy a little break and hope to see you soon or on one of the other 3 tracks.